time, right? You can imagine they want to be closed. It's my robot with my software and my tools and my upsell and additional part components, right? They want total lock-in. But they really have no choice. And even like this week, last year, NVIDIA made the big announcement about they were coming out with their robotics SDK, Isaac. And us in the robotics community were like, God damn it. They've come out with their own thing that's functionally identical but incompatible with what the rest of the world is doing. If they had taken half of that engineering and done it as contribution to ROS, it would be so much further along. So I'm at GTC this week. I just got off a red eye a little while ago. And yeah, so they're, hey, Isaac, it does ROS now. It's open. You can use it with anything. So yeah, but that's a year lost, right? That's painful for us in the community.
Money lost.
It's just everything lost.
Energy.
Yeah. It's and I feel bad for all the people that they talked into using Isaac. So, yeah.
So
GTC.
we're at the early stages of this.
But it's taking off fast, and I'll show you some
That's
things.
why I asked about ROS 2. Where was it in the
Yeah. So there was for the first 2 years, there's quite a bit of resistance in the community to ROS 2 because, you know, I had already had it working on ROS, and it was not quite right, but it was sort of good enough for what, for maybe my particular task. It was kind of good enough. Like, I had figured out how to, shim and Band-Aid and duct tape my way around the limitations.
I knew where the words were.
Yes, exactly. What's happening now, and there's a few things that are forcing it, right? So all the big industrials jumping onto the train has kind of changed the discussion, right? It's no longer like just good enough, right? It's got to be really good. That's been a big part of it. There's been people who have key packages like MoveIt, which is a path planner for robotic arms, doing typically applications are like final finish. So when you do digital manufacturing, it's additive and subtractive. So you print, but then so you got all the printer path planning, and then you add, and then you subtract. So then you take it, you move it onto a CNC robot, and it does all the final finish, drills all the mount points and the like. So this is a critical package, this package called MoveIt, and the MoveIt guys were like, yeah, I don't have time. I'm too busy to port it to ROS 2. So another company in the community said, I'll do it, and that's how we get there. So fault tolerance, scalability, we talked about that. Evolvability, flexibility. Yeah, so you develop your app, you got some flexibility, and Eric and others can tell you more about this. The time decoupling, right? So this is an issue that, what if I have late joiners, right? I have robots that are late to the party. How do I catch them up on what events have occurred and what's the current state of all the things within that?
Not just late to the party, but went missing from the party that came back.
Yeah, well, yeah. So this is all the durable subscription kind of things. Portability, right? So, you can flip between DDS implementations. You can support multiple DDS implementations, which is...
I also think it's important for integratability. So in the old days, you had one ring to rule them all. Somebody would say, oh, I've got this, and everybody had to buy from them.
Right.
And so then you couldn't bring other components in and things. With DDS standardized, somebody can produce a particular component and then start plugging it in to all kinds of different machines. And it doesn't matter which DDS vendor they pick.
Right. And actually with ROS 2, it's even abstracted that they have an abstraction layer for all the communications called ROS.
RFW.
ROS middleware or robot middleware, one of the two. So actually you could do implementations of other things. You could run it on MQTT, you could run it on this, that, and the other thing, but in spite of the flexibility that you could do that, nobody's doing that. Like, everyone is doing DDS. Interoperability, motherhood apple pie. Okay, so we start getting some names. These are going to be way too small to see, but like if you can think of a big industrial, they're involved at this point. So there's a work stream, there's an organization called ROS Industrial, and specifically about taking the open standard, open source ROS, mostly from university and academia, and drag it kicking and screaming into the factory, into the warehouse, into the oil fields, and so forth. So you got a lot of big folks involved there. And so here's some examples. So here's, this is a trivially simple example, but this is our customer ABB using, these are two separate robots with separate controllers, and they're using DDS to coordinate the task. This is a trivially simple example, but it just makes it clear that the robots are working together on the task. So they're handing a ball back and forth. It's not that exciting. This is a more interesting one. So this is at Southwest Research Institute in San Antonio. And this is a beast. So this is a Southwest Research Institute, Air Force, and Boeing joint project. This is a 10,000 kilo mobile robot that has a 10-meter reach. And its job is to, what you want robots for is the jobs that are dull, dangerous, and dirty. And grinding paint off of military airplanes is all three of those, because the paint is made out of the stuff you don't want to breathe, right? And so the workers, to do this, they have these huge heavy grinders, and they do it for like an hour, and then their shoulders hurt and they have to stop. So this robot, they take these big massive grinders, because there's no people in the picture, so it's hard to understand the scale, but each of these little things is like this big, and they put 3 of them on the end of the robot. Here's another one. This is pretty clever. They've actually deconstructed it that each joint, each module of the robot is self-contained and is running ROS2 with DDS. And then they worked out the connection, so you've got, as you start, you can snap them together like Lego pieces. It's got power and Ethernet that passes through, so you can make them as short or as long as you want, and interchangeable actuators. And they've got there's a thing called gazebo, which is what you use for simulation training. So you can put together a new configuration of a never before seen robot. You can train it in simulation and then deploy it to work in the real world. This is where I was yesterday. So ag robot, don't make it angry. It's a very big robot, does very delicate work. Pick strawberries using DDS. This is our friends' autonomous stuff. They're doing a lot of work around AVs. They have the vehicle outfitted with FLIR infrared cameras, and we were standing behind the car watching the monitor. And it's kind of embarrassing, but this guy stood in front of the car, and he's like, he's messing with this stuff, and we're looking at the infrared camera, and we see that there's a whole area on his pants that are a different temperature than the rest of his pants. Apparently he forgot to shake. So,
TMI.
Yeah, I know. So our Tardic friends, so of course, being military, they're like, we want to do exactly what the rest of you are doing, but we're going to make it closed source. So they do ROS-M. So those guys. AV mobility pods. So I'm all about the accessibility. The way ADLINK got me to join is I had this pet project developing a self-driving bus for the elderly and disabled. And ADLINK tried to recruit me. I said, I can't, it's too important. They're, no, we love that. Like, why don't you come join, and we'll give you technology and money. You can work on it full time. Here's a roboticist. So we did that. And then Stevie Wonder came and hung out with us to check it out. So that was fun. But this is another one some friends of mine are doing. And does this play?
Live and IBM at CES this year.
Go to Las Vegas.
Perfect.
This is like test number 1.
Yeah, no pressure.
So running DDS, right? Little self-driving pods. How good is that?
Take me to London.
Okay, part 3, let's go to London.
So that's fun. And then they rolled some out for the blind veterans at a facility in UK. A lot of grass in the UK. We don't have this in Arizona. The Battle Creek, Michigan. So Pratt and Miller, in typical U.S. fashion, they're taking those same vehicles and they are making them bigger for the U.S. population. That's not quite true. What they're doing is they're making them bigger so they can fit wheelchair ramps in them. And so they're rolling these out at the Battle Creek, Michigan VA hospital. And then here's some just random AGV service robots, whatever, running ROS2 with DDS. These are actually using, we manufacture robotics kits that have all the software in DDS in the compute module that you snap into the robot. And a few others. And then of course the ever important cow milking robot. And now they also have another one that feeds the cows. So they feed the cows and they milk the cows, and it's all done using with DDS.
Cows like it?
I don't know.
Are they happy cows?
Well, they haven't complained to me.
They're complaining to the robot, but the robot doesn't listen.
Yeah.
Depends on how cold the robot's hands are.
That's right.
Exactly. And then this is just background noise. If you all have any questions or anything.
Cool. Any questions? Oh, come on. When is a robot going to replace a systems engineer?
Well, so my little girl, she asked me, Daddy, are the robots going to take all of our jobs? And I was like a little shocked, and I was like, thinking for an answer. No, honey, they're here to help us. They're here to help the humans. And she goes, but Daddy, why are you building the robots to take all of our jobs? She's 10, like she should not have to be worrying about this. I am a little worried though.
So you're in Arizona?
Yeah. Yeah, we have our lab in San Jose, but that would require living in San Jose. So my office is in San Jose and I live in Arizona.
Gerardo.
So I have a question. I was actually at the last OSRF ROS meeting that they had, which was very interesting. A lot of people there, like you said, they do it collectively with the robotics, with a big robotics conference, like the week before. But it was interesting to see that even in the big robotics conference, like 4,000 or 5,000 attendees, in the floor show, about half of the demos were running ROS in some form or another. But what I started seeing that, as a statistic, like in the ROS conference, this year for the first time, the number of papers and use cases devoted to ROS2 overtook the ones that were presenting ROS for the first time. So it's exactly what you were saying, that now they are seeing more activity. In terms of deployed systems, I'm sure there's still more ROS deployed than ROS2, but in terms of new activity, there is more happening in ROS2.
Absolutely, and I think part of what's driving that is things like the AVs. So for the autonomous vehicles, just regular vanilla old school ROS is a non-starter for that. And so you really need the things that DDS brings to the ROS architecture. And when it flips, it's going to, and it is flipping right now, but it's flipping hard because you have a big community of people who know ROS. And the difference between, if you know how to develop in ROS, the learning curve to get from ROS to ROS2 is like 10%, right? It's not like you're completely moving to something else. Like it's in the scheme of things, it's a relatively small change. So as that entire community flips into ROS2, it's going to move very fast. And then you got people like Apex AI and the work that they're doing and the investment from.
It sounds like the integration is going to be faster and more successful, which means the products that are out there will also go up.
Yep, and all the products running ROS can be field upgraded to run ROS too.
Okay, we are at break time. So I got the robots to clap on time.
Yes.
When are we not on break time?
It says we go to 3:40. Let's make it to 3:45. We'll just cheat 5 minutes.
Okay, as long as you don't take it from our talks.
No, we just